Today we are going to learn about mastering data cleaning with Python's Pandas. We'll explore techniques for handling missing data, removing duplicates, and standardizing data formats to enhance your data analysis skills. Welcome to our session on mastering data cleaning using Python's Pandas library. In data-driven environments, the accuracy and reliability of your analysis are heavily dependent on the cleanliness of your data. Throughout this video, we'll delve into various techniques to efficiently clean datasets using Pandas. By the end of this session, you'll be equipped to handle missing data, remove duplicates, and standardize data formats effectively. Let's get started with an introduction to Pandas, where you'll learn why it's a crucial tool for any data analyst or scientist.
At the heart of Pandas is the DataFrame, a powerful data structure that allows you to store and manipulate tabular data. Think of a data frame as a table in a database or an Excel spreadsheet. It consists of rows and columns, each capable of holding different types of data, whether they're integers, floats, strings, or more complex data types. Creating a data frame is straightforward. You can construct one from various data sources like dictionaries, lists, or even external files such as CSVs or Excel spreadsheets. Once a data frame is created, you can perform a myriad of operations, filtering rows, selecting specific columns, and performing statistical computations. This flexibility makes data frames an indispensable tool in data cleaning, allowing you to transform messy data into a pristine format ready for analysis.
Missing data is a common challenge in data analysis, but Pandas offers robust methods to tackle it. First, you need to identify the missing data, which Pandas makes easy with functions like isnull and notnull. These functions allow you to locate missing entries and decide on a strategy to handle them. One approach is to fill missing values using the fillNum method. You might fill these gaps with a constant value, like 0, or use an aggregate statistic such as the mean or median of the column. Alternatively, you could drop rows or columns with missing values using the dropNum function, which is useful when the missing data is too extensive or when its removal won't significantly impact your analysis. In cases where neither filling nor dropping is suitable, more sophisticated imputation strategies can be employed, like interpolation or predictive modeling, to estimate missing values. Duplicate data entries can skew your analysis and lead to incorrect conclusions. Pandas provides straightforward methods to identify and remove duplicates effectively. The duplicated function helps you identify duplicate rows in a data frame, optionally considering a subset of columns if only specific fields should be unique. Once identified, you can remove these duplicates using the drop_duplicates method, which retains the first occurrence by default but can be configured to keep the last or even drop all duplicates. It's essential to ensure that removing duplicates doesn't inadvertently remove necessary data, so understanding your dataset's context is crucial. Maintaining data integrity while cleaning necessitates a careful balance, ensuring that your cleansed dataset remains representative of the original data. Data type consistency is vital for accurate data analysis, as Pandas operations depend heavily on the types of data stored in data frames. Incorrect data types can lead to unexpected errors and misleading results. The astype function in Pandas is your go-to for converting data types. Whether you need to convert strings to integers, floats to booleans, or any other conversion, astype makes it straightforward. For date and time data, the do_datetime function is invaluable, ensuring that date strings are converted into Pandas datetime objects, which can be manipulated for comprehensive time series analysis. Categorical data, on the other hand, can be optimized using the category data type, reducing memory usage and enhancing performance. Consistent data types across your data frame ensure that your analysis remains reliable and insightful. Filtering and sorting are two fundamental operations in data analysis that help you focus on the most relevant data. Pandas provides various ways to filter your data. You can apply conditions directly to your data frame, selecting rows where a condition is met. For more complex criteria, the query method allows you to express filtering conditions as a string, enhancing readability and maintainability. Once you've filtered the data, sorting it using sort_values helps in organizing the data meaningfully. You can sort by one or multiple columns and choose whether the sorting should be ascending or descending. Multi-level sorting is particularly useful when dealing with hierarchical data, allowing you to prioritize which columns should take precedence in the ordering. These filtering and sorting capabilities are essential for extracting actionable insights from your datasets.
Pandas is incredibly flexible when it comes to applying functions across your data to clean and transform it. The apply function allows you to apply any custom function to each row or column in your data frame. This is particularly useful for tasks like standardizing data formats, performing calculations, or implementing complex transformations. You can use Python's lambda functions within apply to write concise, inline functions tailored to your specific needs. For large datasets, vectorization is a powerful technique to consider. Instead of iterating through each row or column, vectorized operations process entire arrays at once, significantly enhancing computational efficiency. Whether you're normalizing data, correcting data entry errors, or performing more advanced data transformations, the ability to apply custom functions in Pandas is an invaluable tool in your data cleaning arsenal. Data validation is a critical step in ensuring that your data is accurate and reliable. With Pandas, you can implement several practices to validate your data effectively. Assert statements are a simple yet powerful way to enforce data constraints. For example, you can assert that no missing values exist in a critical column or that a column's values fall within a specific range. Consistency checks are also crucial, such as ensuring that categorical data only contains expected categories or that numeric data is within reasonable bounds. Data validation helps maintain data integrity, preventing errors from propagating through your analysis. By incorporating these validation techniques into your data cleaning workflow, you ensure that your insights are based on trustworthy data. To solidify our understanding, let's explore some real-world examples of data cleaning using Pandas. Imagine you're working with a dataset of customer orders, but you notice inconsistencies in date formats, missing customer IDs, and duplicate entries for the same order. First, you'd identify and standardize date formats using _datetime, ensuring all dates are uniformly processed. Next, handle missing customer IDs by filling them with placeholder values or using imputation techniques if suitable. Duplicate orders can be identified and removed using duplicated and drop _duplicates, ensuring the dataset accurately reflects distinct transactions. By applying the techniques we've discussed, you can transform a messy, unreliable dataset into a structured, actionable resource ready for analysis. These case studies not only reinforce the concepts learned but also demonstrate how these skills are applied in real-world scenarios.
While Pandas provides powerful tools for data cleaning, it's essential to be aware of common pitfalls that can undermine your efforts. One frequent mistake is overlooking data type conversions. Failing to convert strings to numbers or dates can lead to errors in analysis and misleading insights. Another pitfall is ignoring duplicate entries, which can skew results and affect data integrity. Mismanaging missing data, whether by overly aggressive dropping or inappropriate imputation, can also compromise your dataset's accuracy. Neglecting data validation further exacerbates these issues, allowing errors to slip through unnoticed. Finally, while optimizing for performance is important, it must not come at the expense of accuracy. Balancing these considerations is key to mastering data cleaning with Pandas and ensuring your analyses are both efficient and reliable.
In conclusion, mastering data cleaning with Pandas is an essential skill for anyone involved in data analysis or data science. We've covered a range of techniques, from handling missing values and removing duplicates to converting data types and applying functions. Each of these skills plays a crucial role in ensuring your datasets are clean, consistent, and ready for analysis. Remember, the quality of your data directly impacts the insights you can derive, making data cleaning a foundational practice in any data-driven endeavor. I encourage you to practice these techniques and explore further resources to deepen your understanding. With Pandas as your tool, you're well equipped to tackle any data cleaning challenge that comes your way. Thank you for joining us, and happy data cleaning!